So, is it audible clearly? Is it audible? Yes, okay, great. Fine. So, today we are going to discuss Cauchy's method of characteristics. So, this method actually is used to solve the first order nonlinear differential equations, right? So, this is actually one method actually which is adapted for solving the nonlinear differential equation. Till now, whatever we have discussed is only the linear differential equations, right, which can be solved in an easier manner. So, this method a little complicated and little lengthier procedure, and then so I strongly suggest not to attempt this question in case if it is coming in the examination. Try to put it in the optional. Got it? Because so this method actually it is so complicated that actually it will take a lot of time, and still there is a possibility of making a lot of mistakes. Got it? So here actually what this Cauchy's method of characteristics says is, so he has given a set of 5 differential equations, set of 5 ODE or 5 different simultaneous differential equations are given, ordinary differential equations. Differential equations so were given, which were called as the characteristics. The characteristics. So these are the characteristics. So he has given a list of 5 different ordinary differential equations which you have to solve it. Now this Cauchy's method of characteristics. So this method is going to be used. Suppose if the differential equation is of the form x comma y comma z comma p comma q equal to 0. Now this is a first order differential equation. So maybe a nonlinear differential equation. Now here x, y, z, p, q. So all are actually different variables that are involved in it. So p is dou z by dou x and q is dou z by dou y, and z is a function of x comma y, right? So here actually these differential equations, so the solution of this will represent a plane. The solution of this differential equation will represent a surface called as an integral surface. So this is called as an integral surface. So the method actually that is going to be adapted is, suppose actually this particular differential equation, so whose solution is some random function of x comma y comma z, right? Now let us consider a point which we call as the initial point, where this is x naught comma y naught comma z naught comma p naught comma q naught. So this is a point which will represent randomly a surface element, obviously, right? So this is the derivative of the function with respect to x, and this is the derivative of the function with respect to y. Now this particular point is nothing but an elemental surface with associated normal to this. So this is the ds element in case of vector calculus what we have treated. Now this particular strip or the point actually will represent an elemental surface associated with all these parameters. Now the solution of the differential equation is nothing but the integral surface which will represent all these kind of points joined together. It will form a surface. Got it or not? Right? So this kind of point. So this is one point I have considered, x naught, y naught, z naught, p naught and q naught will represent an elemental surface. And then the solution of the differential equation for a set of arbitrary constants will give you a surface, or which is an integral surface of all these kind of elemental surfaces together. So which will nothing but the solution of the partial differential equation represented by this equation. For this, actually, the methodology that is going to be adopted is, so initially, so we have to assume as the parametric form. So initially, let x naught, y naught, z naught, p naught and q naught be expressed in a parametric form. Be expressed in a parametric form. Let it be lambda. That means x naught is expressed as lambda and y naught is expressed as lambda and z naught is expressed as lambda and p naught is expressed as lambda and q naught is also expressed in terms of lambda. Now, these were actually initially expressed in terms of lambda, which are nothing but the parametric form. So, these are nothing but the parametric form, right? So, this parametric form of the initial conditions is going to be applied on the original equation, that is f of x comma y comma z comma p comma q, right? Where the parameter of this is ideally, so x of t, y of t and z of t and p of t, q of t. Now, this is the original parametric form, which is nothing but the general solution. So, the general solution is expressed in terms of t and the initial condition of the general solution is expressed in terms of lambda. And finally, with the help of this differential equation, we will be trying to eliminate this lambda and t to get the solution of this particular differential equation. That is the methodology which we are going to use it. In that case, we will have to use in between the set of 5 differential equations suggested by the Cauchy, which are nothing but the characteristic equations. Those characteristic equations are, you can note down this. So, in the parametric form of t, so this is expressed as dx by dt is equal to dou f by dou x and dy by dt is equal to dou f by dou y and dz by dt is equal to, so p into dou f by dou x plus q into dou f by dou y. So, this is dou f by dou p and q into dou f by dou q. And one more characteristic equation is dou p by dou t is, sorry, dp by dt is equal to minus dou f by dou x minus p into dou f by dou z. And one more last is dq by dt is equal to minus dou f by dou y minus q into dou f by dou z. Now, these set of 5 differential simultaneous equations we call as the characteristic equations. So, these things you need to remember it. Got it? So, given the differential equation, so that differential equation, you have to identify the initial conditions in terms of lambda, and then, so this lambda, in terms of lambda, we mean here, this lambda value is at t is equal to 0, which is nothing but the master parametric form. So, at t is equal to 0, at t is equal to t naught, or at t is equal to 0, this is the parametric form. Given this parametric form as t, randomly if you express in terms of t, you are going to get the solution of this one. Finally, eliminate the t value to get the final solution for it. Got it? Understood or not? So, you have to note down these things and then actually you have to memorize this to solve this equation. Note down this. Done? So based on this understanding, now let us solve one problem. So note down this problem. Find the characteristics of the equation. Find the characteristic equation. Characteristics of the equation PQ equal to Z and determine the integral surface and determine the integral surface which passes through the parabola x is equal to 0, comma y square is equal to z. So actually this is the problem statement. So this has to pass through the parabola equation given by x is equal to 0 and y square is equal to z. And then we have to identify the integral surface of it for the differential equation PQ is equal to z. Now the initial parametric form. So let x naught, y naught, z naught, p naught, q naught be the initial values represented in the parametric form. As lambda. So then x is 0 and if you take y is equal to lambda, z will be lambda square, right? So if you take x is equal to lambda, so y is equal to lambda, obviously z will be the lambda square, and then so z is a function of x comma y. Then dou z by dou x is given as just a minute, I am getting a call. Okay. So this value, So Z naught can be expressed as Z naught of lambda is equal to P naught into X naught dash of lambda plus Q naught into Y naught dash of lambda. So this is actually the derivative. So this derivative value, Z being the function of X comma Y. So this is dou Z by dou X into X naught dash and dou Z by dou Y into Y naught dash. This is at the initial condition. Here the P naught value and Q naught value we have to be solving in the parametric form. So this is the X value and Y value, Z values are given in the parametric form. Even Z naught dash actually, so this value, so Z naught actually is equal to lambda square. So the derivative of that is with respect to lambda is 2 lambda is equal to, so P naught into derivative of X naught with respect to lambda is 0 plus Q naught into derivative of Y naught with respect to lambda, this is 1. So this is 2 lambda is equal to Q naught. So one more variable we have got, Q naught is equal to 2 lambda. And the next value left over for us is P naught. For that P naught, what you can solve is, that is P naught into Q naught is equal to Z naught. So Z naught value actually we have got as lambda square. So and Q naught value we have got 2 lambda. So 2 lambda into P naught is equal to lambda square. So this lambda will cancel out and then P naught is equal to lambda by 2. So this is the P naught value which is equal to lambda by 2. So I hope you understood this one. So Z actually being the function of X comma Y. So if you want to take any perimeter, that is so dz by d lambda is equal to dou Z by dou X into dx by d lambda plus dou Z by dou Y into dy by d lambda. So this is what actually is written as Z naught dash is equal to of lambda is equal to P naught into X naught dash of lambda plus Q naught into Y naught dash of lambda. So this is the formula actually what I have used here. I hope you understood that. Got it? Understood or not? Okay. So once you got these values, then actually we have to use the Cauchy's characteristic equations to get the final solution. So those characteristic equations are given it here. Got it? Okay. I think so. There is a change here. This is P and this is Q. Yeah. Yeah. So from this actually, once you got these values, I'll write those equations here. So X naught equal to 0, Y naught is equal to lambda, Z naught is equal to lambda square, and P naught is equal to lambda by 2, and Q naught is equal to 2 lambda. So these are the set of initial conditions in terms of the parametric form what we have got. Now, the characteristics equations are, so the original equation PQ equal to Z which we need to solve. The characteristic equations are dx by dt is equal to dou f by dou p. Now here this function is nothing but pq minus z equal to 0. So this is the function f. pq minus z is equal to 0. Now dx by dt is equal to dou f by dou p. So this is the function f, right? So this I call this as p of x comma y comma z comma p comma q is equal to PQ minus Z is equal to 0. So this is the function F. Now dou F by dou P is nothing but Q. Dou P is equal to Q. Similarly, dy by dt is equal to dou F by dou Q is equal to, that is P. And then dz by dt is equal to P times of dou F by dou P. Dou F by dou P is Q minus Q times of dou F by dou Q, that is P. So this is sorry, this is plus, right? Yeah. So 2 times of PQ. Yeah. Then the next one is dP by dt is equal to minus of dou F by dou X minus dou F by dou X minus P times of dou F by dou Z. So this is dou F by dou X is 0 minus P times of dou F by dou Z is minus 1, which is equal to P. And similarly, dQ by dt is equal to minus of dou F by dou Y and then minus Q times of dou F by dou Z. So this is dou F by dou Y is again 0 minus Q times of dou F by dou Z is again minus 1. This is Q. So finally what we have got is dx by dt is equal to Q. Equation number 1, and then dy by dt equal to P. So this is equation number 2, and dz by dt equal to 2pq. This is equation number 3. And the next equation is dp by dt is equal to P, and dq by dt is equal to Q. So these are the 5 different characteristic equations which we have got in terms of the parametric form, which is nothing but T in this case, right? So once you got this characteristic equation, so we have to solve all these 5 differential equations to get the expression in terms of T. So but T is again, right, a function of the initial conditions. That initial conditions again a function of lambda. Now this lambda and P needs to be eliminated. How are we finding with respect to x? So this function, right? So this is the function what we have got. Here PQ minus Z equal to 0 is the function. So this is the function F. Now, so I call this as F of PQ x y z. Now here this is independent of x and independent of y. It is dependent on P, Q and Z, this function. Now the derivative with respect to x will vanish. Yeah. Got it? Now here actually we need to be solving this differential equation. Dx by dt equal to Q, and one more equation is dp by dt is again Q. So then actually, so dx by dt is equal to dp by dt. This is one equation. And another equation is dy by dt is equal to P, and dy by dt equal to P, and another equation is, so dp by dt. So this is dq by dt. Yeah, dx by dt equal to Q, and this is equation number 1 is equal to equation number dp by dt equal to P. So this is equation number, this is 3, this is 4, and this is 5. So equation number 5 are equivalent. So dx by dt and dq by dt. Similarly, dy by dt is equal to p and dp by dt. So these two are equivalent. So equation number 2 and 4 are equal. And dz by dt equal to 2pq, you leave it as it is. Yeah. So this one, so if you try to solve this one, so this is dx minus dq equal to 0. So then x minus q, if you integrate it, this is constant c1, and if you integrate this equation, then y minus p is equal to c2. So these two are the two different equations. And the next equation is dp, so this is dz by dt equal to 2 times of pq. dz by dt is equal to 2 times of pq, but pq is equal to z. So this is 2 times of z. Then dz by 2z is equal to dt. So this, if you integrate it, then I call this to this side, then log z is equal to 2t into some constant c, c4 I call. So this is z is equal to e power 2t into some constant c4. So we have got again a set of equations. This is equation number 6, this is equation number 7, and this is equation number 8. Got it? Note down till this point. Note it down. Done? Okay. So once you got these values, then I'll just write all the equations whatever we have got. So one equation is x minus q equal to c1 and y minus p equal to c2. These two are two different equations. And z equal to c3, or I call this as c3. c3 into e power 2t. And then another equation is, we have got actually from the characteristic equation, that is dp by dt equal to p we have got. Similarly, dq by dt, from the characteristic equation we have got q also. Then dp by p is equal to dt and dq by q is equal to dt. Now if you integrate on either sides, then this is going to be log p equal to c4 into t and log q is equal to c5 into t, or p is equal to, so some constant, I call this again as the c4, c4 dash I call c5 dash. So c4 into e power t and q is equal to c5 into e power t, right? So these are the characteristic equation solutions which we have got. And for this actually, the initial conditions, what we have got is x naught equal to 0, y naught equal to lambda, z naught is equal to lambda square, p naught equal to lambda by 2, and q naught is equal to 2 lambda. So those initial conditions, if you substitute it here, so x naught minus q naught is equal to c1. So now actually these are the parametric forms. X naught is 0 and then minus 2 lambda equal to c1. And another equation is, that is y naught, so y naught minus p naught equal to c2. Then y naught value is lambda and then minus p naught value is lambda by 2 equal to c2. So it implies c1 is equal to minus 2 lambda and c2 is equal to lambda minus lambda by 2. So this is again lambda by 2, and the next equation is z is equal to z naught is equal to c3 e power 2t. So c3 z naught value lambda square is equal to c3 into e power 2 into t naught value. So t naught is 0. So this lambda parameter is at t is equal to 0. So these are the parametric equations. So now actually the initial conditions are at t is equal to 0. So at t is equal to 0, we are substituting it here. This is going to be 0. It implies c3 is equal to lambda square. And then the c4 value you can find out, that is p is equal to p naught is equal to c4 into e power 0. It implies p naught value is lambda by 2. C4 is equal to lambda by 2. And the next one is q naught is equal to c5 into e power t. It implies c5 is equal to q naught value is 2 lambda. So this is 2 lambda. So this is how actually we have got all the values, all the arbitrary constants in terms of lambda. Got it? Now if I substitute here, so x minus q is equal to, x minus q is equal to c1. C1 is 2 lambda minus 2 lambda, and y minus p. So y minus p is equal to c2, which is equal to lambda by 2, and then z is equal to, so z value we have got c3 is equal to lambda square into e power 2t, and then p value we have got, p is equal to lambda by 2 times e power t, and q is equal to 2 lambda times e power t. Now actually we have arrived to the last stage. So these are the values actually we have got after solving all these equations, simultaneous differential equations, which you need to further simplify from this equation, from this set of 5 equations. So this is equation number 10, 11, 12, 13, 14. Now actually, out of all these equations, eliminate lambda and t. Then we get the final solution. So this is the methodology. Got it? See this, summary. So actually the thing is, initial conditions actually we have got, right? So these are the initial conditions. What do we mean by the initial conditions? Now the final solution actually what we are expressing is in terms of the parametric form t. Now the parametric form, the initial conditions we mean, that is at t is equal to 0, which is the parametric equation which was expressed in terms of lambda. That means these the values actually x naught, y naught, z naught, p naught, q naught values are at t is equal to 0, which we have expressed in terms of the parametric form like this. And these values, that is at t is equal to 0, we are trying to find out the solutions of the characteristic equation arbitrary constants in terms of lambda, which mean if we are trying to find out the equation values in terms of lambda, meaning at t is equal to 0. So in this equations, all the equations whatever we have solved here, these equations actually at t is equal to 0, which are nothing but the initial conditions. Those initial conditions are the one actually which we have assumed in the parametric form of lambda. So at t is equal to 0, we are trying to solve the arbitrary constant values in terms of lambda. That means as and when there is a requirement of the value of t, you need to substitute as 0. And then correspondingly, if it is z0, you have to correspondingly express the z0 value in terms of lambda. Got it? So this is how actually you have to solve it. Now finally, out of all these equations, you have to eliminate lambda and t out of all these 5 equations. Got it? Yeah, note down till this point. Done? Okay. Now actually from these equations, so out of all these 5 equations, so now actually we will further simplify this. That is x minus q is equal to minus 2 lambda. X minus q value, you can express this as 2 lambda into e power t. E power t is equal to minus 2 lambda. And then the next equation is y minus p. Y minus p, p value is lambda by 2 times of e power t is equal to lambda by 2. So if you further simplify this equation, this is x equal to minus 2 lambda. If you take it out, then 1 minus e power t, and here y is equal to lambda by 2. If you take it out, 1 minus e power t. So this is one set of equations. Then if you take this ratio, x by y is equal to, or actually just leave it as it is, then actually z value is coming out to be lambda square times of e power 2t. Now the lambda 2 value actually we need to express. Yeah, I think so there is a mistake. Yeah, so this is plus, right? So if you bring this to this side, then lambda by 2 times of 1 plus e power t. Then from this equation, if you solve it, so x by y is equal to, so minus 2 times of 1 minus e power minus t, e power t divided by 1 by 2 times of 1 plus e power t. So this is minus 4, 1 minus e power t divided by 1 plus e power t. So for this actually, from this actually, you can find out the value of e power t in terms of x and y. So this e power t value, if you find it out, I think so this is going to be x plus 4y divided by 4y minus x. So this is x plus 4y divided by 4y minus x. So this is the value of e power t. Once you solve these two equations, so this is the ratio of x by y. You can simplify this ratio to express e power t equal to. Then actually this is the value you are going to get it. Now this value, if you put it in any of the equations, you are going to get the value of lambda. So the lambda value is going to be, okay, I'll just write it here. So e power t value we can get as x plus 4y divided by 4y minus x. And similarly, the lambda value, you can solve those equations to get the lambda value. That you can get it as 4y minus x divided by 4. So this is equation number 15 and this is equation number 16. So once you got these values, then you can substitute in any of the equations let us say in this equation z actually, if you substitute it, z is equal to 4y minus x divided by 4 whole square into e power 2t. So e power t is x plus 4y divided by 4y minus x whole square. So this is the value of z. So this z value, finally what you are going to get it as 16z is equal to 4y plus x whole square. 16z is equal to 4y plus x whole square. Yeah, obviously. So this is the characteristic or the integral surface. So this equation 17 represents the integral surface. Integral surface represents the integral surface represented by the PDE given by PQ equal to Z. So this long procedure needs to be done for each and every problem. That is the difficulty in this. So here the steps involved are, so I'll just repeat the steps that are involved in this particular equation is to solve any non-linear first order partial differential equation of a general equation. So the beautifulness of this particular thing is it will give the solution for any random non-linear partial differential equation. That is the advantage of it. But the procedure is so complicated. So the complicated procedure as per Cauchy's theorem actually, so what he mentioned is he has given a 5 set of differential equations, ordinary differential equations, which we call that as the characteristic equations. Those set of 5 characteristic equations will be used to solve the values of x value, y value, z value, p value, q value. So these are the 5 different values are there. Hence we have 5 different variables equations are there, ordinary differential equations. Now we start the problem statement by assuming the initial conditions as x naught, y naught, z naught, p naught, q naught in terms of some random parameter called lambda, which is nothing but indirectly a parameter of t when t equal to 0. So this lambda is the value of the parameter when t is equal to 0, which is a master parametric form for the general equation, which we call the integral equation. Now there actually first you have to identify the initial conditions in terms of the lambda, and then for that actually you have to express x naught, y naught, z naught, p naught, q naught. All the 5 different variables you need to express in terms of lambda. For that the methodology what we have used is he will be giving anyway one equation, which is nothing but the point which is passing through the parabola, he said. So that point needs to be expressed in terms of the parametric form first. So once you express the parametric form, then actually express the z value in terms of z is equal to dou f, so dou z by dou x into dou x by dou lambda plus dou z by dou y into dou y by dou lambda. So lambda is the parametric form. So but z is the given equation, z is equal to x square, y square in this particular case, right? So once you get all the values in terms of lambda, then you express the integral surface with the help of the characteristic equation. Those 5 different characteristic equations, you solve it first for the given set of equation. That is, the equation here in this case is pq minus z is equal to 0. That equation which we call as the f. For that actually he has given the 5 different characteristic equation, that is dx by dt is equal to dou x by dou f by dou p, like that actually he has given. Those 5 equations you solve it, which are nothing but the characteristic equation. For that, substitute the initial conditions that are x naught, y naught, z naught, p naught and q naught, which were expressed in terms of lambda. Then if you substitute all those initial conditions, then what you are going to left is you will get the values of the arbitrary constants in a single parameter called lambda. Then in certain cases actually where there is a possibility of leaving t will be there. So that t value you have to substitute as t is equal to 0, because that's where we started analyzing, which is nothing but the parametric form of the original given shape, that is the parabola in this case. So that lambda value is nothing but at t is equal to 0. Assuming that, so t value substitute 0 and remaining values you put it in terms of lambda, then you are going to arrive at 5 different equations which you can solve for. So those 5 different equations are, these are the 5 equations. In everywhere actually you can see only either lambda or t. Now all these 5 equations you have to avoid p, lambda, q and t, and then replace everything else in terms of x, y, z alone. then which will represent the integral surface, which is nothing but the solution of the partial differential equation for the equation pq minus z is equal to 0. Got it? Any questions on this? Any questions on this? Fine. So this is the last topic. So I have covered all the aspects of the partial differential equations without leaving any single term. So this will be the complete and comprehensive syllabus. So based on this, actually, if you practice the problems, then actually that will be of much use for you. In case if you have any doubt, you can contact me on Telegram. So this will be the last class for this particular batch. So no more classes will be conducted from now onwards. So yeah. So if you have any questions, you can let me know. Yeah, you can contact. Yeah, you can contact me. No problem. Got it? Yeah. So thank you. So wish you all the very best. So hope you perform well in the upcoming exam. So keep you updated. Yeah. So thank you. Good night. Yeah. Bye bye.